So now that we have some basic notation under our belt, I'd like to discuss the best case scenario for what could occur when we're studying a system of equations. And that's if the augmented matrix that represents the system is in reduced row echelon form. So there's a first layer of analysis we can perform on a system of equations if we're in reduced row echelon form. So here's the vocabulary. So note here that in our example that we're giving here, our augmented matrix is in reduced row echelon form. And here I've gone ahead and boxed the pivots. So here we have 3 pivots. We say that the variables that are represented by pivot columns are called dependent variables. So this is an adjective that describes a certain type of variable in the system. So in this augmented matrix, we see that the pivots are in the first, second, and fifth columns. So we would say here that the dependent variables of this system are x1, x2, and x5. The other variables, so the variables that are represented in non-pivot columns, are called free variables. So here, in our augmented matrix that's in reduced row echelon form, the non-pivot columns are columns 3 and 4, here, at least to the left of the vertical bar. And the variables that are represented by these columns are x3 and x4. So we call x3 and x4 free variables. So the idea here is that if you give me an augmented matrix that's in reduced row echelon form, I can identify the dependent variables by looking at the variables that are represented by pivot columns. Again, in this example, those are the variables x1, x2, and x5. So we call x1, x2, x5 dependent here. And I can identify the free variables by looking at the variables represented by non-pivot columns. In this case, those are the variables x3 and x4. So that's the first thing we do when we look at an augmented matrix in reduced row echelon form, is we identify the dependent variables and the free variables. And the next layer of analysis tells us exactly when a reduced row echelon form system is inconsistent. So a system is inconsistent if the augmented column contains a pivot. So here we're looking at a new example, and this new example is in reduced row echelon form. And let's look at the pivots. So the first pivot is in the 1, 1 position. The second pivot is in the 2, 2 position. And then the third pivot is in the 3, 5 position over here. Well, this last pivot is in the augmented column. And I want us to consider the consequences of this. So this pivot in the augmented column, well, that means that we have a 1 here, and there's zeros before that 1. Well, think about which equation is being represented by this third row of this matrix. So this is telling us we're inconsistent, and the reason is because the third row here is giving us the equation 0 times x1 plus 0 times x2 plus 0 times x3 plus 0 times x4 equals 1, which is the equation 0 equals 1, which is impossible. And this always happens if we have a pivot in the augmented column of a reduced row echelon form system. So a system is inconsistent if there's a pivot in the augmented column, and on the other hand, the system is consistent if the augmented column contains no pivot. So this is the second layer of analysis that we perform if our system is in reduced row echelon form. The first thing we do is we locate the dependent and free variables. The second thing we do is we determine whether or not the system is consistent by verifying whether or not there's a pivot in the augmented column. Another thing to observe here is that we can talk about the rank of the coefficient matrix of a system in reduced row echelon form. And the rank is the number of pivot columns, but remember that the pivot columns in the coefficient matrix correspond to dependent variables. So the rank of the coefficient matrix is the number of dependent variables. So in this example, we have pivots in the first, second, and fifth columns of the coefficient matrix. And this tells us, first of all, that the dependent variables are x1, x2, and x5. And also, consequently, that the rank is equal to 3. So the rank of the coefficient matrix is the number of dependent variables. And then on the other hand, the nullity is the number of free variables. Here, the free variables are x3 and x4, And that's exactly the nullity of the coefficient matrix. So number of dependent variables is the rank, number of free variables is the nullity. So we can take this analysis and put this analysis into a famous theorem called the Roche-Capelli theorem. The Roche-Capelli theorem categorizes every reduced row echelon form system into three categories. So every reduced row echelon form system falls into one of the following three categories. The first category is the category of inconsistent systems. So remember, a system is inconsistent if there is a pivot in the augmented column. If our system is inconsistent, that means there are zero solutions to the system. And again, the reason is because if we had a pivot in the augmented column, that would give us an equation that said 0 equals 1, which is of course impossible. The next category is the category of consistent systems that have only one solution. So another category is the category of consistent systems that have only one solution. And so here what we're looking at is an example of a system that has only one solution. The next category is the category of consistent systems that have infinite solutions, and this is the only other category. So every system is either inconsistent with zero solutions, consistent with one solution, or consistent with infinitely many solutions. And of course, the next question is, what distinguishes a consistent system with only one solution from a consistent system with infinitely many solutions? And the answer is the existence of free variables. So the number of solutions to a consistent system is controlled by the nullity. If the nullity is equal to 0 in the coefficient matrix, that means that there are 0 free variables, and consequently, as long as we're consistent, we'll get one solution, but no more. So on the other hand, if the system is consistent and the nullity is greater than 0, that means that there are free variables, and we'll end up, and which means that we will end up with infinitely many solutions to the system. So this is the analysis we do when we're confronted with a reduced row echelon form system. And the idea is that we don't need to do any arithmetic here to perform this analysis as long as we're in reduced row echelon form. So the first thing I do when I'm confronted with a reduced row echelon form system is I ask myself, which of these three categories does my system fall into? Is it inconsistent with no solutions, meaning that there's a pivot in the augmented column? Or is it consistent, meaning there's not a pivot in the augmented column? And if I am consistent, are there free variables or are there no free variables?